Good evening, Standoff. And this will be the ultimate report in our session by Clint Gibler about scaling security and DevSecOps. He is going to share a great wisdom with us, so stay tuned and let's enjoy his speech. Thank you.
Hey, everyone. Thank you so much for coming, and thank you to the organizers for having me. This is actually my first time speaking at Standoff, so I'm very honored to be here. So today, I'm going to be presenting an opinionated guide to scaling your company's security. So over the past couple of years, I've spent hundreds, perhaps thousands of hours studying how different companies have scaled their security, and not the ad hoc one-off wins, but the things that have truly systematically, scalably raised their security bar over the long term. So my goal in this talk is to take a vast amount of ideas and material and distill it down into one place so that you can take the best tips and tactics that work for you. Not everything may apply, but hopefully some will. All right, so let's get into it. All right, again, so this is going to be pulling from a number of conference talks, dozens, perhaps hundreds of blog posts, tools, and in-person conversations I've had with security engineers at many companies. So the company logos on this slide are just some of the companies whose work I'm going to reference in this talk. A little bit about me before we get into it. I am the head of security research at R2C. We're a San Francisco-based startup building the latest and greatest in static analysis. Previously, I was a technical director and research director at NCC Group, and before that, I was a grad student at UC Davis. Here are a couple of topics I'm personally quite interested in, so if you're also into them, feel free to reach out on Twitter, LinkedIn, or just email me. I'd be happy to chat about them. Okay, so this talk has three main parts. So first, I'm going to discuss some sort of big picture ideas, mindsets, and principles, sort of lenses through which to view the world. And then the bulk of this talk is going to be some specific tactics and things you can do to really scale your company's security. And finally, we're going to have an action plan where we sort of tie everything together so that you can apply the things that you learn in this talk immediately and in the medium term and in the long term. All right, so let's get into it. So some mindsets and principles. This first one is probably not a surprise to anyone. You want to automate as much as possible. So every company has security teams that are always time and person limited, and fundamentally, you need to automate to scale. Another thing I see at many companies these days is the security team needs to build guardrails and not be gatekeepers. That is, you need to minimize the number of times you say no to the development teams. Otherwise, you're sort of damaging that relationship too much. And Netflix calls this sort of the paved road. Like, how can we sort of build a secure foundation that developers can build upon? And I think Asta has a nice blog post about this. Many companies are choosing high signal, low noise tools and alerting. That is, it may be better to miss some issues than to drown in alerts that are false positives and don't matter. Another idea is, when we're building a product as a company, we spend a lot of time thinking about the user interface and the UX and making sure that's really nice. And I think that as security teams, we need to treat developers and engineers as our customers. How can we fit into their existing tools and workflows? Can we make the secure way easier, faster, or otherwise better than the current way? And some ways to do that include, building telemetry, logging, or other useful features that developers want anyway into these security primitives that we provide for them so that it makes them actively want to use them. Another idea is self-service security. So can we provide tools and services that developers can use without the security team interacting with them at all? So I wrote about a couple of these in a bit more detail in this Tech Beacon blog post, so feel free to check those out. So just to condense this sort of whole talk into one meme, broke is finding individual bugs, and woke is scalably reducing risk. In life as well as in security, I think we always have choices between whether we're investing in sort of now or medium or long term, and I'm going to push you very strongly in this talk to focus on the long term. So ask yourself things like, of my near and medium-term tasks, which will provide the most long-term strategic value? Can I do a near-term task a little bit differently to make it more useful later? And also, what sub-problems can I solve precisely and at scale? In security, there's a number of things we can do, right? So we have static and dynamic analysis. We have pen testing and bug bounty. We have writing secure wrapper libraries and threat modeling, runtime detection, and fuzzing. So the reason I'm pointing out all of these tools and approaches is that instead of thinking, there's a given tool that I'm using, how do I make this tool better? Instead think, what problem am I trying to solve? What outcome do I want? And then reflect, is this tool, is this fundamental approach the right one in this situation? And another thing that I think is important to call out is, choosing what to ignore is also critical, right? Because we have to let some fires burn so that we can focus on the highest leverage things. So Adam and I were chatting on LinkedIn a bit ago, and one thing he said that I thought was very insightful is, the question isn't, is a given activity useful, but rather, is this activity a better use of our time than something else? Because again, we have a finite amount of time. Another way I like to think about things is targeting vulnerabilities by complexity, like how hard they are to find, or the vulnerability class. So you can imagine things that don't require much analysis complexity. For example, determining if an API or web app is using TLS, if it's using the right security headers, if it's just calling a dangerous function, and so forth. And then in sort of the medium difficulty, we have your standard OWASP bugs, cross-site scripting, SQL injection, and so forth. And then in the hard group, we have complex multi-step bugs, maybe business logic flaws, or abusing intended features. So when you're first starting your security program, you may think, let's just solve all of these problems with automated tools, or you might say, let's just pen test our problems away. But as your security program matures, what I see at a number of companies is a breakdown that looks more like this. So as much as possible, we're solving sort of the easy and a lot of the medium and some of the hard cases with the secure defaults and really leaning into those. And using automated tools for some sort of easy and medium cases and a little bit for hard, but those are a bit harder to sort of codify in automated tools. Bug bounty certainly has a role in finding some easy and medium type issues and a little bit of hard. And the point here is like pen testing, ideally the sort of key value here is for these medium and hard complexity issues. And then there's also runtime monitoring for types of issues that are just difficult to find any other way. Okay, so some key takeaways. Solve as many of your problems as possible with secure defaults. Automated tools won't solve all of your problems. Bug bounty can provide some decent coverage of the low and medium hanging fruit. Use pen testing for the hard problems. This is where it's providing value. If most of the results you're getting from your pen test are these sort of like easy and medium type issues, then you're not sort of using it to its ideal effectiveness. And runtime monitoring is useful for bugs that are just too hard or inefficient to find in other ways. So that's what I was thinking. Let's look at what other companies are saying as well. So here we have Patrick and Asta of Netflix, a talk they gave at AppSec Cali a few years ago. So look on the left-hand side under de-emphasized, we see manual testing and traditional vulnerability scanning. And then on the right-hand side under heavily emphasized, we see killing bug classes, not just individual bugs. Paved road, which is this sort of how can we build secure libraries that developers can just use and security just transparently happens for them, and so forth. This was another talk by Netflix the year after by Scott and Isha. And notice how this investment in secure by default is sort of one of the sort of core things they're building on, and that it's only growing over time in terms of priority. Okay, so let's talk a bit about scaling your company's security. First, let's discuss some of the fundamentals. So I say these are fundamentals not because they're easy. In fact, they're quite hard to do well, but rather they're the fundamentals because they are high leverage activities that you can build very sort of effective scalable wins on top of. So this is sort of the groundwork. And that is vulnerability management, continuous scanning, and asset inventory. So let's look at those in a bit more detail. Okay, vulnerability management. This is knowing where you are now and also knowing if your future efforts actually work, right? So you don't want to spend 2 or 3 months on some big ambitious project and then find out that it didn't actually move the needle for you. So ideally, what a successful vulnerability management program looks like, these are just some example criteria. You want to minimize the friction for developers as well as the security team. Ideally, all vulnerabilities are tracked in the same system as normal bugs. And every vulnerability is processed through the same workflow, regardless of how you found it, whether that was bug bounty, pen testing tools, and so forth. And you want to track some relevant metadata. So what sort of metadata? Ideally, you want the relevant code base that was affected and the team and org responsible. Which vulnerability class was it? Was it related to access controls, cross-site scripting, and so forth? And I would say OWASP top 10, in my opinion, is a bit too broad. Ideally, you want something with a bit more detailed taxonomy, like BugCrowd has a VRT. And basically, you want maybe, say, like 20 to 40 issue classes. You don't want so few that there are unrelated types of issues grouped together, but you don't want so many that your buckets of vulnerabilities only have one each in them. You want to be able to look for trends. And we'll talk about that more later in this talk. You want to know the risk and severity and impact of issues, and also how was it found? Was it pen testing, bug bounty, and so forth. Some other useful context. You can, like, what was the root cause of this issue? What was the pull request introducing or fixing it? And were there any mitigating factors? So a couple of talks in this space that I think are useful. The Art of Vulnerability Management by Alex, Data-Driven Bug Bounty by Arkady Tetelman. And we're going to look at a couple of figures from his talk because I think they're quite useful. So this is the first one. So this is the open security vulnerabilities by priority. So we can see sort of are our blocker issues or critical or major issues trending up or down over time. So ideally, we would like them to trend down if we're doing a good job. Here we're seeing the open vulnerabilities by sub-team and priority. So we can see on the left-hand side here, there's this one team that has way more open issues than the other team. So by visualizing the information in this way, we can quickly and easily have the intuition like, oh, we should go meet with this team to understand, is there a type of issue they're not understanding? Is there a way that we can help unblock them? Why is it taking them longer to address these issues? An idea I got from Emre of Salesforce is if you have a bug bounty program and you're tracking payouts by vulnerability class, you can actually assign an exact dollar amount for how much a given vulnerability class is costing your company. So in this made-up example, we can see access controls are responsible for the most sort of payouts. So you might say, oh, as an AppSec team, perhaps we want to invest in buying that down. And this can also be useful for justifying security investments to executive leadership. Another useful thing, this is from a talk by Domino's, where you have this sort of executive dashboard where you can see at a high level without any security domain expertise, these projects and sub-teams are green, their security is doing well, others are red. And this creates sort of a healthy competition between executives and owners of different business units. So this is also can be useful. Okay, let's talk about continuous scanning. So this is one of the most common important ideas in sort of modern DevSecOps. And the idea is continuously scan new code with static and dynamic tools. So how this tends to look in practice is sort of static analysis on developer machines, as well as in sort of code hosting as new code is pushed. And then in a test or QA environment, doing dynamic testing like web app scanning, DAST, container scanning, network vulnerability scanning, fuzzing, and so forth. So due to time constraints, we're not going to talk about the dynamic approaches, but I believe I have some backup slides that you can check out on those if you wish. Okay, so again, a lot of people have been talking about building like this continuous code scanning AppSec pipeline. So this is probably not a full list, but here's a bunch I was able to find. So Twitter, Salesforce, Netflix, Cisco, PayPal, Coinbase, Datadog, Dow Jones, and more. So all of these talks, each company approaches things a little bit differently, but there are some core trends that it seems everyone generally agrees on. Okay, so let's run through those. It's important to focus on iteration speed, so adding or removing tools, testing new rules. Generally, people are choosing to scan pull requests. You could scan every commit, but it tends to be a bit too noisy. For example, there could be work in progress commits that never get merged. Ideally, scans should be fast, say 5-10 minutes, because you want to give developers feedback while the context is fresh. If they have to go back after days or weeks, they're less likely to remember the context and thus less likely to fix it quickly. If you do want to do more in-depth scans, say daily or weekly, you can do that asynchronously, but really I think fast feedback here is king. Ideally, you want to show tool findings within the developer systems. For example, as a comment on a pull request, you don't want to make them log into a separate security tool. Again, that's bad developer user experience. You want to focus on high signal checks, things that when they fire, they're almost always true. If this is not the case, generally you're going to cause some ill will with the developers, and it's just too much operational overhead for the security team. You want to capture metrics, what are the common finding types, the false positive rate, and so forth. You'll probably need to build some deduplication and whitelisting logic, and being able to map reduce over your code and live systems is really useful. And we'll look at a concrete example of that in a second. So here's some more talks that I think have some good ideas in this space. So another way I like to look at it is, there's actually a range of complexity of static analysis. A lot of people think it's just one thing or the other. So on the easy, simple end, you have grep, which is just regexes, where you're operating on strings. And on the other end, sort of under high complexity, you have sort of control and data flow analysis, like traditional SAS, where you can reason about how data flows through a system. So what's nice about grep and regexes, it's very fast, but it's not expressive. And SAS tools are nice because they're expressive, but they're also slow and a bit noisy. They tend to have a lot of false positives. But what many people aren't as aware of is there's actually a middle ground here that combines some of the benefits of both. This is sort of security linting or abstract syntax tree matching. So it tends to be very fast, but it's also source code aware, and it can match source code structures like, okay, match a conditional if this is called in the expression or this is not in the else clause or something like that. So I think that this is a very interesting space that I see a number of companies starting to work in. So Justin Collins, the creator of Brakeman, gave a talk about this sort of lightweight custom static analysis at AppSec USA. My colleague Daniel and I gave a talk about it at ShellCon a few years later. And Instagram has a really nice blog post about it as well. So if you were to build your own sort of lightweight static analysis, what would that look like? Generally, you're going to go from source code and then parse it into an abstract syntax tree and then try to find bugs on that representation. So you could use a language-specific parser or a parser generator like Antler, or in my opinion, the best approach is sort of a multi-language processor like Semantic or Babelfish. Okay, so why do we want to be language aware? Let's look at an illustrative example. So let's say we wanted to find all calls to exec, the function call. So we might say, rip grep, which is just a faster grep, exec, open paren, and then some like A through Z. So while that may work in many cases, there's a lot of times we're going to mess up, right? So in this first example at the top, the exec call could be across multiple lines. It could be a different function, or we might, so those we might miss. And the things that we might flag that we don't want to flag is when we are in a comment or in a string literal. So there's actually another tool called SemGrep, which my company is building, which is an open source tool that's basically trying to make a very simple, easy to use grep, but that is aware of source code structure and things like that. So to find exec on this right-hand side, you could just say exec open parens ... and then that would find all calls to exec regardless of what's in the arguments. You can also, for example, find all conditionals where the if and else body are the same. You can find hard-coded secrets by saying quote ... So that's going to match any string literal, regardless of the contents. And yeah, this sounds interesting. It's open source, LGPL. You can find it on GitHub. It supports Go, Java, JavaScript, JSON, Python, Ruby, and a bunch of other languages. You can write your own custom rules quite easily, but there's also a number of security rule sets right out of the box that you can use. Another thing is, ideally, security tools aren't just giving developers more work. Ideally, you're saving them some work. So you can also supply auto fixes. So you flag an issue and then you're like, oh, developer, please change it to this. We're also working with OWASP to basically make it easy to automatically verify if your code is compliant with the sort of security best practices of the ASVS standard, or to automatically find code that doesn't, say, follow cheat sheets best practices. So that's some potentially interesting collaborations you can check out as well. And some developers are writing some correctness and best practices checks as well, like, for example, enforcing business logic. Not just security checks. So it's a pretty versatile tool. Pretty much if you want to find code, whether you're seeking to find bugs or seeking to just have a high quality code that you can sort of scale across an organization, you might find it useful. Okay, so we've talked a bit about how to scan. But what do we actually want to look for? So a couple of things. So one is high signal vulnerability checks and security anti-patterns. So things that are like, if I see this, it's probably going to be a problem. For example, disabling TLS verification. It can also be useful for blocking banned or dangerous functions. For example, calling to exec or eval or other things are just inherently dangerous. Mozilla has some nice ESLint plugins to make that easy. You might also want to look for detecting security relevant code additions. So this isn't necessarily a bug, but hey, you're like adding some crypto code. So like, what are you trying to do there? Are you meaning to hash versus encrypt? Let's figure out what you're trying to do. You could alert on sensitive file system changes or sensitive file changes. So say authorization, authentication, login flow, things that should rarely change. You might want to say, oh, if a developer changes this as a security professional, I want to know. So these second two cases are interesting because they're not necessarily bugs, but they're things that probably you care about. So there are many open source tools. Here's a couple that I think are pretty good. Of course, looking for vulnerabilities in open source dependencies is also very important. So I like this Black Hat talk by Aladdin that talks about that in a bit of nice detail. And there's tools like OWASP Dependency Check or various commercial tools. Another topic that's been quite popular recently is doing static analysis on infrastructure as code. So there's a couple of talks on it at the top, and I've listed a number of tools that you can check out as well. Okay, so key takeaways here. You want to build the capability to scan every pull request, code base, and deploy service. Ideally, you want high signal checks only. And again, we're trying to ensure a security baseline here. We're not necessarily trying to find every bug. And we can scan for not just bugs, but missing security controls, security relevant changes, and so forth. Okay, last fundamental, asset inventory. What is it? Depends on who you ask. To me, it's a list of the things you own, whether that's code, servers, databases, and so forth. So there's a couple of common approaches I see. So you can do black box external network based, where you're doing sort of OSN certificate transparency and things like that. You can do white box external network based, where you give a tool read access to your cloud environment, and then it hits a bunch of AWS APIs and sort of aggregates the information that way. And you can also do sort of like a white box holistic approach, where you're integrating not just with your cloud provider, but your code hosting and many other systems. And it's sort of modeling every asset you have as an organization. Okay, so really, we want to know, like, what do we own, and then how do they all connect? So I think a good place to start is focusing on your code and your cloud environment. So maybe you have a meta info file in each repo that says who's the owning team, who's the team lead, who's the security point of contact. And then for your cloud environment, you're keeping track of, say, the live servers, databases, load balancers, which services are we using, where are our credentials, secrets, API tokens, and so forth. So Sasha of Lyft gave a nice talk about Lyft cryptography, a tool they open sourced, which I'll talk about in a second, where it's basically you're taking all your assets and representing them as a graph, and then you can do security queries by querying across this graph. Erkang described a sort of commercial version of cartography his company is building. And Rob and Oscar presented a very nice survey of different asset inventory tools and really got into sort of the trade-offs of each, which I think is quite nice. All right, so this is a screenshot from cartography. So here we are basically mapping out our AWS environment. So the sort of pink nodes are AWS accounts, and then the red ones are RDS instances, and we can sort of see the relationships by the edges in the graph. And all of this is just stored in a graph database like Neo4j. So having an asset inventory lets you answer questions like which RDS instances have encryption turned off, which EC2 instances are directly exposed to the internet. And let's look at a little bit sort of a maybe realistic and a bit more complicated example. So let's say your company is running struts and you think, I think you probably know where this is going. Let's say a new critical RCE has been published. It has a catchy logo and name, and you're probably a bit upset about it. But there is a released curl POC to determine if a service is vulnerable. So what can you do if you have a strong asset inventory? So, well, first, if you, again, have the capability to sort of map reduce across all of your systems, first, you can use that to run this curl POC across all of the servers that you know are live to determine which are affected. You can then trace from the affected services to the code responsible. You can then figure out which developer is in charge of that service, and then automatically send them, for example, an email, a Slack message, Jira ticket, or so forth. So the idea here is we are taking a sort of critical incident response scenario and then very quickly responding to it and handling it in perhaps sort of minutes or an hour or two instead of days. So you're taking the sort of vulnerability window and ideally shrinking it as much as possible. So this example is about incident response, but really it's sort of generally applicable in many situations. Okay, so let's talk about scaling our efforts. So let's talk about threat modeling, security engineering, and detection and response. So I hear this again and again from many companies. You can't threat model every story. So what do you focus on? I see three primary approaches in practice. So the first is self-service questionnaires. So when a development team is building a new feature, they fill out sort of a questionnaire that says, which sensitive data are you touching? What sort of language and tech stack are you using? Are you going to be parsing XML or doing other sort of sensitive operations? And then this computes a risk score. It gives the developers a set of sort of security control recommendations. And then the AppSec team reaches out to the development teams building the highest risk services. The second, so add lightweight threat modeling to the SDLC. So maybe as sprint planning is happening and developers are figuring out, what is the acceptance criteria, also have them ask some questions like, okay, what are we building? How could this be abused? And what can we do to sort of prevent this, these sorts of attacks? So this is a nice way to sort of distribute the work across development teams. So the AppSec team doesn't have to attend every sprint planning meeting. And the last threat model is code. So this is actually a bit different depending on who you ask, but to me, it means sort of writing sort of security integration tests that test security properties continuously as development happens. So basically, the point of all of these is, the developers do sort of the front load of the work, and security engineers get involved with the highest risk services and new features. Okay, let's talk about security engineering. So the core idea here is we want to build libraries and tools that are secure by default for development teams. And the framework and tech choices you make really matter. You can actually mitigate entire classes of vulnerabilities by making the right choices. So I've included this picture of the Wild West on the right because really I think that's where web security was maybe 10, 15 years ago, where cross-site scripting and SQL injection were everywhere. But I think now in modern frameworks that do output encoding by default, that have tight integrations with object relational mappers, that sort of kill SQL injection by default, I think these sort of security mechanisms being built into the core sort of building blocks that developers use really has immensely improved security. So when you're deciding, what sort of custom internal secure defaults we can build, consider things like managing secrets, anything related to crypto, authentication, authorization, SQL, file system access, and so forth. And Abe had a nice blog post about this as well. So here's some anecdotes. So one company I was talking with said that they ported their front end to React, and that basically killed cross-site scripting. Another said that they wrote a data model wrapper library that all accesses of user data had to go through, and that basically killed SQL injection. So the key takeaway here is, if something is hard to do securely, if developers need to be aware of a couple of different threats in order to not shoot themselves in the foot, just build a secure by default implementation and have them use it. A quote I like from Asta is, hitch your security wagon to developer productivity. Ideally, the secure version should have an even better dev user experience than the old way. Another key trick that I think is pretty neat is if you integrate security at the right points. So for example, if there is a repo that developers clone to spin up a new microservice or a new code base, like if you put security mechanisms into there, anytime anyone clones it, then they will be getting sort of the security defaults that you've put in there by free, and you don't have to convince anyone to use it. It's just sort of there automatically. So this is a nice way to get sort of widespread adoption without a heavy lift on your part. Okay, let's talk about detection and response. So one idea that I think is pretty cool is this Slack IR bot. So basically, the idea is when something sketchy happens, prompt the originating user with a Slack bot question saying, hey, I just saw this happen. Was this you? And then confirm via 2FA and only escalate to the SOC team if the user says no. So again, we are pushing validation to developers to free up security engineer time. So what I think is very cool about this is Ryan Huber of Slack wrote about this in 2016 in a blog post, and then Dropbox wrote about it in a blog post in 2017 and released a proof of concept implementation. And then Pinterest gave a conference talk at AppSec USA about this a year later. So we see this same idea moving across organizations, and I think that that's pretty cool. Another idea is from Dropbox, who's trying to automate as much of this threat detection as possible. So basically, when something sketchy happens, there's a Kafka alert, which goes to this separate system called Alertbox, which then grabs context from a bunch of different systems, like information related to the users and hosts and processes involved. that information is passed to another service called Forerunner, which returns and then runs a Jupyter notebook that is corresponding to that type of alert. And then all of that is passed to this other service called Covenant that is provided to the analyst. And basically, they investigate the issue in this Jupyter notebook. So the process is very repeatable because what to do is standardized in the notebook. And also the results are documented, so it's easy to go back to and see what happened in the future. Another idea is sort of automating your SOC security runbooks. So, for a given event type, can we write a security runbook that just defines how exactly we respond? Maybe we spin up a series of AWS Lambdas to call various security products or custom scripts we write. So Twilio released Sockless, a tool to sort of make this easy to do at scale. Auth0 wrote a blog post about it, and AWS Security Hub has sort of a blog post series about these sorts of things. So the key takeaways here: we want to push the first-line triage to the originating user as appropriate. Any context needed for a human analyst to proceed, we want to gather this automatically, so they just do things that humans are good at. And we want to document runbooks for how to respond to different events, and as much as possible, automate them. Okay, so let's talk about the last thing, security endgame. So I paid a graphic artist a lot of money to make this next image, so I hope you appreciate it. Bam, security endgame. Okay, so we're going to talk about automating least privilege, targeting entire vulnerability classes, and sort of a case study, and also enforcing invariance. Okay, so this talk is by Travis McPeak of Netflix, and they built a pretty cool tool where basically new applications at Netflix are by default granted a base set of AWS permissions. And then this tool repo kid is going to gather data about the app's behavior and automatically remove AWS permissions that it doesn't need based on the API calls it's making. So basically, each app is going to converge to least privilege with essentially no security team interaction. And so applications that don't use any permissions converge to zero permissions. And sort of coming at it from another angle, Kennard of Salesforce released a tool called Policy Sentry, which tries to make it as easy as possible to generate a sort of least privilege policy from the get-go rather than removing permissions over time. So what are the key takeaways here? So I think that these approaches are very powerful because the ongoing time requirements from the security team are essentially none other than maintaining the tools. But the security benefit and the risk reduction are huge, right? So anytime you can find opportunities like these, I think you should take them. Because really, if you think about it, what we're doing is we're maximizing the ratio of security ROI to the ongoing time requirements for the security team. Okay, so targeting vulnerability classes. So again, if you are having a strong vulnerability management program, you can then say, oh, these types of issues, for example, in this graph, say security misconfigurations, these are the most popular issue. We should maybe focus on building some secure defaults so these happen less. Okay, so this is based on a number of projects I did at NCC Group where companies came to us and said, hey, we're not getting a lot of value out of this SaaS tool. Like, can you review how we're doing things and see what makes sense for us? So sort of the initial ask is, how do we get more value from the current SaaS tool? But that's a little bit vague. What are they really asking? And I think sort of what they're getting at is, how can we make our SaaS tool find more bugs of higher criticality with less manual time? But if you take a step back, really, I think what we care about is, how can we find bugs more efficiently regardless of approach? And at the end of the day, I think what we all care about is, given limited AppSec engineer time and budget, what's the best way for us to reduce overall risk? And again, this is not tool or approach specific. Okay, so here's how you can do this at your company. This is what I did. So basically, aggregate your vulnerabilities over the past couple of quarters, maybe 1 to 2 years. Group them by vulnerability class, like access controls, cross-site screen, and so forth. You could also group them by how you found them. Was it pen testing, bug bounty, and so forth. And you probably want to weight them by the severity, risk, or impact. And then review them sort of like each bucket at a time and think, what can find or prevent these issues at scale? So our goal here is to minimize cost, either direct cost, such as bug bounty and pen testing, or maybe tool licensing, as well as, AppSec time in terms of like if you have to find it manually or triage results. And ask yourself questions like, is one method finding most of our high security vulnerabilities? And are there any sort of success stories or lessons we've learned that have worked well for our org or team in the past? Also useful to consider. So this is another figure that I think is pretty neat. So if we're keeping track of vulnerabilities by source, we can see, for say HackerOne or a third-party pen test, how many of these issues are we end up resolving or marking as duplicate or won't fix? Because this gives you some feedback, like which of these approaches are actually working for us in practice, not just in theory. And then maybe you want to double down on those. Okay, so let's look at an example. So let's say you do a time audit of your AppSec team to figure out, where are we spending the most time? So you might say like, we're spending some time threat modeling, we're spending some time manually running security tools, we're dealing with XXE a lot. So you're actually we're spending probably the most of our time on XXE. Let's like drill into that. How is that actually breaking down in practice? So you might say, well, we're doing some developer training around it. We are triaging bug bounty submissions. We're working with developers to fix it. We're validating the fix. We're maybe configuring our SAST and DAST tools to find these types of issues and maybe triaging the results. Like all of these things are recurring, ongoing sort of operational overhead time for your security team that you're having to continually do month after month, year after year. But if you were to instead do the following, if we were to, say, build a safe by default wrapper library for parsing XML that disables DTDs and does all the things that makes it safe, and then we taught the developers about this new library and then rolled it out everywhere, and then scanned every new pull request for XML parsing code that doesn't use this library, then we're done. Like all of these things that we used to have to do, we no longer have to spend time on. So this approach was discussed by Morgan of DocuSign about how they eliminated regex DOS, XXE, Open Redirects, and SSRF via this combination of secure by default libraries and ensuring their use. So if we go back to our time, previously we were spending perhaps like a third of our time dealing with XXE, but because of building a secure by default library and making sure everyone used it, bam, like all of those things that we used to do, we don't have to worry about anymore. So this frees up our team to invest in other things. Maybe we then say, hey, we're spending a lot of time, manually running security tools. Let's automate some of those. And then bam, now we've actually taken essentially 50% of our time that we used to spend on these other things, and we freed ourselves up to then progressively target more and more classes of problems and issues we have to deal with. So the idea here is we're basically building a sort of AppSec effectiveness snowball where we are becoming more and more leveraged and effective over time, even with the same number of people and the same resources. So if this process sounds interesting to you, actually my colleague Isaac and I gave an entire talk just on this idea and sort of really breaking down the methodology step by step to try to make it as sort of concrete and actionable as possible. So feel free to check that out. And we're also going to write a blog post about it soon. So because of this, I really think that the security engineering is the compound interest of security. So it's not necessarily going to give you outsized returns on day one. You might have to sort of continuously put time and money into this sort of security engineering bank, but over time, it's going to really make your team much higher leveraged and more effective. Also just wanted to call out, as I wrote the previous slide, coding yourself is kind of awkward. And of course, Gandhi said that. Okay, so key takeaways here. Use your vulnerability history to determine where to invest effort. Which are the issues you've had the most in the past. Consider different vulnerability classes, what's finding them, what is their impact. Again, we're trying to figure out what is the most effective way in terms of accept time and money to reduce risk. And again, solving bug classes rather than one-off bug finding amplifies your effectiveness. Okay, last thing, enforcing invariance. So the core idea here is we want to enforce or alert on things that should either always or never be true. So to give you an example, you might say, our AWS instances should never be accessible on all ports to the whole internet. So Datadog wrote about how they have a Lambda that if they see an EC2 instance that pops up with this property, it'll just auto shut it down. You might say manual changes should never be made through the AWS console. We should do things through Terraform. Arkady wrote a blog post about how to sort of alert on that. Maybe you say, in my organizations, we should never use these regions or cloud services. So if there's instances in other regions or they use other services, this is a red flag. Either a developer is doing something I don't expect, or perhaps we've been compromised. And you could even do this, per app or per service. So this idea was discussed by Will and Travis in their AppSec Cali talk that I think is quite excellent. So the key takeaways here are: what are things in your environment that should either always or never be true? For example, with regards to your cloud environment, your security controls, your code, authentication, authorization, and so forth. And then which of these can you programmatically enforce or alert on? And again, the sort of key insight here is if it doesn't take any context to make the decision, you can automate it, and it requires no operational time for your security team. Again, we're just trying to become more and more leveraged over time. Just taking all these different classes of issues that we previously used to have to spend time on and knocking them out as much as possible. I encourage you to ask yourself, how is what we're doing now making us more effective in the future? And if it's not, I would consider deprioritizing it. And of course, Gandhi said that as well. Whew, okay, we talked about a lot of things. So let's start wrapping things up in an action plan that brings everything together. So we'll talk a little bit about what you can start doing immediately, for example, next week, in the medium term, in the next, say, 3 to 9 months, and over the longer term. So first, you want to assess where you are. So evaluate your fundamentals in terms of vulnerability management, continuous scanning, and asset inventory. And you may want to brainstorm with security leadership as well as your subject matter experts on the engineering side. What information do we have now? Which sort of vulnerability and asset inventory information would we like to have? Are there any promising projects that immediately stick out? And then after that, we want to really build, right? So nail the fundamentals. Can we build a solid foundation upon which we can do very high leveraged initiatives after this? And I encourage you to do a bite-sized project first, prioritized based on your sort of historical vulnerability data, or maybe your company's business factors and risk. So the key phrase here is bite-sized. You don't want to say, oh, this idea excites me, I'm going to do something that takes 2 years to show payoff. Like ideally, you want to do something that shows some measurable value within a couple of weeks so that you can prove to yourself as well as executive leadership that it is meaningful and worthwhile to pursue these sort of more ambitious projects rather than sort of day-to-day firefighting. All right, and then in the future, we want to scale. So we want to become more highly leveraged with our time by targeting vulnerability classes. We want to invest in projects with high security ROI and minimal ongoing time requirements, for example, automating least privilege and invariance. And we want to focus on areas that meaningfully raise our security bar. So there are many projects that may seem sort of technically very interesting, but if they don't actually raise our security bar, they may not be the best for us to invest in. Okay, so let's wrap things up. I watched every talk from AppSec Cali 2019 a bit ago and wrote detailed summaries for each of them. So if you enjoyed this talk where I covered a bunch of different material and sort of aggregated it and distilled it into one place, you might want to check out that blog post. It can hopefully save you a number of hours. I also write a newsletter called TLDRSec, which is free, where I have sort of a weekly summary of the best tools and links, summaries of various talks, and also original research that I do. So if this sort of thing suits your fancy, consider checking it out. All right, so you can access these slides by going to this bit.ly link at the top. There's also some extended backup slides in the B-Sides SF version of this talk. Feel free to reach out on Twitter or LinkedIn. I would love to chat with you. Again, my newsletter is TLDRSec, and just wanted to thank you so much for your time. It was my honor being here, and I look forward to your questions in the chat or just directly online. So have a great rest of your day.